Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to the Voice of the Cape Matric online revision program this afternoon. And our subject today is on physics. So we invite all our grade 12 students preparing for the preliminary examinations as well as the final exams to follow on this lesson, join us. And also, if you know of any grade 12 students who might require or benefit from these lessons, please do like and share this post, inshallah. So yes, I am currently standing in for Amir. He will be here shortly. You know how Cape Town traffic goes. It's very unpredictable. So Amir will be joining us a bit later. We didn't want to keep all our students waiting. I'm sure many of the learners who are busy preparing for physics, for the physics examination. I think every bit of assistance and guidance and extra lessons does really come in handy. I want to welcome our facilitator for this afternoon, being a second time on this platform for this particular series of the annual Matric Online Revision Program, none other than Zainab Afrika, and she is a third year chemical science student at the University of the Western Cape, and she's also a tutor at Supreme Scholar. Now, also to those of you who might be thinking about what it is you want to study once you've completed grade 12, well, our proud sponsor for this series is the Two Oceans Graduate Institute, and they are an accredited online education platform, or rather provider, where you can become a primary or high school teacher. And they also offer studies where you can actually conduct the lessons from the comfort of your home. So you can obviously find the details on the running credits of this particular segment online, and you can visit the website, which is www.togi.co.za. Well, that is obviously very important to note. But let's welcome our facilitator for this afternoon, Zainab. Assalamu alaikum. Welcome back.
Wa alaikum salam wa rahmatullahi wa barakatuh. Shukran, Sister Kanita, for that introduction. And welcome everybody to our second, basically our part two of our physics revision for the grade 12s. So today we are basically going to be doing part two of impulse and momentum. And just before we get into the whole physics aspect, and before I do a little bit of recap, and before I continue with our lesson today, I just basically want to give some tips for the grade 12s as they head into this kind of stressful season of the year. I was once in grade 12, kind of feels like very long ago. I'm not that old though. And I understand the pressure that we all feel. I understand the anxiety we all feel, and I understand the expectations that we have of ourselves, and that maybe our parents or our guardians or our school teachers might have of us as well. And so that is all fair and well enough. And that is sort of good in the sense that it gives you the motivation to sort of work hard, to sort of give it your best. But also don't forget that you cannot run everybody has to run their own race. Your parents are there to help you, they're there to guide you, they're there to give you all the necessary tools, and so are your teachers. But at the end of the day, it's going to be you and yourself alone in that exam. And so I cannot stress this enough, and I wish somebody had told me this when I was back in Matric, is that try as much as possible, as much as we feel like we don't list sometimes, or sometimes we feel like, you know what, we have more time, because we always think we have more time. Trust me, when you get into the working world or you even get to university, time is never enough. We are always pushing deadlines, we are always trying to get things done, and I think maybe a lot of people can attest to that as well. And so what I want to say to you guys is that try and pace yourselves, okay? I'm going to try and give you tips and tricks as for the next few weeks as we go on with the series, but pace yourselves well enough so that when you get to the exam, you are not filled with anxiety of, oh, I didn't study this and I didn't study that. So every week I'll try and give you guys a little bit of tips that work. Some things might work for you, some things might not. Take what works for you and apply it if you will, right? And so with physics, the one thing that I think I want you guys just to understand is that you're obviously writing out of 150 marks, right? And there are 12 questions, whether it's Newton's laws, whether it's impulse and momentum, whether it's vertical projectile motion, whether it's electrostatics, whatever the topic is, okay? One of the tips that I'm going to give you that is maybe going to help you, maybe that you can start working towards, is that every section of your exam that you're going to write is going to have a definition, and those definitions are worth 2 marks. So you can already say from now already that you are walking into the exam with 24 out of 150. Why? Because they're going to ask you define Newton's laws, right? They're going to ask you define Ohm's law. They're going to ask you, I don't know, define the work energy theorem, right? They're going to ask you, and each of those definitions are 2 marks. So already out of the bat or out of the hat already, you can already prepare yourself by knowing that out of the 150 marks, I already got 24. You guys can calculate how much, what percent is that, okay? So take it one step at a time. Do not, I know you've heard this probably countless times already, do not study the night before. Trust me, it's not going to work, okay? Where you might, if you could have maybe paced yourself and worked before the time, you might have gotten perhaps, let's say, 60% or an 80%, whereas the night before might have given you a 40% or 50%, right? It's all up to you and how much effort you're going to put in. Whatever you put in, I'm sure you've heard this, is what you're going to get out. Okay, so that is just my little rant. And so we're going to start with impulse and momentum part 2. I'm just going to do a quick recap for those who might have forgotten, or for those who are new, or those who are just joining us for this first session. We're just going to do a little bit of a recap, and then we are going to go into part 2 of impulse and momentum. Okay, so we went through the contents for the lesson. We basically wanted to know how we define impulse and momentum. We wanted basically to interpret the formulas, to understand what is this formula actually telling me. I know physics and mathematics can be very challenging subjects for many, and part of it has got to do with a lot of reasons, but I think most of the time is we don't really understand what the question is asking us. And what I'm going to do is that I'm going to give you, maybe I'm probably thinking in the next lesson, but even in this lesson, I'll give you a standard way of asking a question, and then I'm going to give you the same question, the exact same question. You need to do the exact same calculation, but it's just asked differently, or it's just asked more complicated, or using a different terminology, but it's exactly the same thing. And then we're going to contrast the two and see, okay, what are the things that I need to look out for? So like I said, we want to also understand how we're going to interpret the formulas, and knowing definitions are very important. And I'm not talking specifically about just the definitions pertaining to physics, but I'm talking about what does it mean to analyze? What does it mean to differentiate? What does it mean when the question says compare? What does it mean when the question says explain or define or calculate? Okay, so these are all words that mean different things, and it means different things, but it also guides you into how you need to answer the question. So if I'm saying compare, I'm basically going to analyze two different things, and I'm going to give the differences between the two. If it's saying analyze, if it's saying explain or differentiate or calculate, then it means there's certain things that I have to do in order for me to come to the right answer. Okay, so we're going to look at different sorts of questions. Okay, or we're going to look at questions that are asked in different ways, but technically the outcome is going to be the same. Okay, so I think that is where most of our issues lie, is where we are struggling to interpret the question. We might know the content, we might know how to do, I don't know, Newton's laws, we know the formula, but now how do we apply this formula to what the question is asking? Okay, and then we're going to do some questions on that. We spoke a little bit about physics. I basically explained why physics is important, why do we study and understand it. And not everybody is inclined to mathematics and physics, right? But physics is important because it basically describes motion, okay? We need to understand why gravity works the way it does, okay? And we use this through things like velocity, electric field, kinetic energy. It governs how the universe works, okay? The laws of physics are applied in our everyday lives, and it's applied everywhere, okay? And so we basically want to understand what are the fundamental things that basically explain or define the universe, and then we want to understand the relationships between those things, okay? So how do we find the relationship between mass and velocity and acceleration? How are those things related? Okay. Then we obviously went over basically the topics for paper 1. And so, like I said, we are going to strike a deal that we already have 24 marks, okay? So we are talking about the 24 marks of the definitions for each section. You're going to get 12 questions. Each of them are weighed differently, okay? Out of those 12 questions, each section has a definition component. So you need to basically just memorize. Copy paste. If that works for you, you're basically just memorizing a simple definition for each section. And so we agree, or we have a deal now that you already have 24 out of 150. Okay? We are manifesting that, inshallah. So basically you have 150 marks. Out of the 150 marks, the 30 marks would be, 20 marks would be multiple choice, true or false. But note that can be tricky, okay? That it seems easy, true or false, just picking, it's not any minimal. It's still you trying to apply the knowledge that you've learned in class in order to answer those questions. It might not be a long section, but it's going to be tricky because the answers might be very similar. And so the options, okay, might leave you doubting yourself. And so that's how they trick you. They give you different options, but that's more tricky than actually you trying to solve it, because maybe then if you do solve it, you are more certain of your answer than them giving you a list of options and you just have to guess the right one. Okay, and so of those 20 marks, we have multiple choice and we have true or false, or we have match column A with column B. And then the 130 marks. So technically, the 24 marks that I was talking about lies in the 130 marks that's left. Okay, so basically that's how your questions is structured. Your paper will be structured, and I'm sure you're not unfamiliar to the structure of the paper. Okay, so quick recap. We are defining impulse and momentum, the very first section of physics that you needed to be introduced to. Okay, and so we first started with momentum, and I know some certain schools or certain teachers start with impulse, but there's a reason why I decided to start with momentum. Okay, and so what did we say, if anyone remembers? Those of us who are new here, we said that basically momentum has got to do with mass. Okay, so the minute you think momentum, I use M&M, mass in motion. M&M, the sweets. So mass in motion. Okay, that's how I think about momentum, because you cannot get something to move it's massless. Okay, in an ideal world. When you get to university, inshallah, next year, and for those of you who are going to study astrophysics and all of those kind of things, and going into the natural science faculty, you will learn about Einstein's, and I said this last week, you will learn about Einstein's theory of special relativity, which is a very advanced topic, and I kind of did it for like one semester, but it's very interesting for background knowledge, because I'm not a physics major, I'm a chemistry major, but nonetheless. So when we talk about momentum, we speak about mass in motion. So for our understanding, for this lesson and for our purpose, we understand that something cannot move if it doesn't have mass. Think about anything, okay? Anything that you can tangibly see, touch, and feel, okay? It has mass, okay? And so when we speak about momentum, we're speaking about an object's mass, or an object's motion due to its mass. Okay, so it says there that the more mass an object has, the more momentum it's going to have. Okay, because it's going to have more velocity. Okay, so think about it like this. If I am pushing a trolley, let's say a 10-kilogram trolley, like I filled my trolley and it's 10 kilograms and I'm pushing it, it's heavier, right? So it has a larger mass, which means it's going to have a higher momentum, right? However, if I just add like a few things like toilet paper and I add, I don't know, a packet of chips in my trolley and I'm pushing my trolley, it's lighter, okay? It has a lighter mass, which means it's going to have less momentum, okay? So, sorry about that. Okay, so basically, when we're speaking about momentum, we associated a specific equation to momentum. And so momentum is mass in motion, motion velocity. When something is moving, it has velocity, okay? So momentum is equal to mass times velocity, okay? And then the symbol, the mathematical symbol, or represent the momentum in terms of mathematics is P is equal to M. Okay, now I don't know if this was stressed enough, but units are very, 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 very important. Very important. Okay, because when you calculate something, and remember, your guys are going to have external markers. okay, and external examinators, which means it's not marked by a teacher who knows you, who knew you from grade 8 or who knows you for the whole year. So, because Liam did not write centimeters or meters at the end of his answer, I'm just going to give him the mark. They don't know you, you don't know them. That's the whole point, which means they're expecting you to give information correctly. When you give an answer of 30, what? Okay, what is it? So you need to say newtons or meters or kilograms or meters squared. You need to explain, because remember, we are talking about physics. It's not maths, okay? We are talking about physics. Physics, remember what we said about physics. Physics describes motion, okay? And there are specific units that describe. So the minute you say meters, I know you're talking about distance. The minute you say kilograms, I know you're talking about mass. The minute you say meters per second, I know you're talking about acceleration. The minute you say newtons, I know you are talking about force, because we are describing physical quantities that describe motion. So it's very important, and I cannot stress this enough. It's very important for you to write your units. And so how are we going to remember momentum? Mass is in kilograms, velocity is in meters per second. So the units for momentum will just be kilograms, meters per second. You combine the two because it's multiplication. Okay, I hope that makes sense. Please, whatever answer we get or whatever question you do in your going forward, in your prelims and in your finals, please do not forget your units. All right. So we went through these questions last week, and so I'm just going to verbally just explain them again, and then we are going to go on to today's topic. So we said that momentum is mass in motion. Okay, it describes and it's an if you want to put it in physics terms, it's an object's velocity due to its mass. Okay, so we have the questions in front of us are asking us to determine the momentum of, number one, a 60 kilogram truck moving eastward at 9 meters per second. Now you need two things for momentum. P is equal to, if I go back, P is equal to M times V. We are looking for P because they are asking us for this object's momentum. So the mass in our case is kilograms. Remember, if it was in grams, you would have to change it to kilograms. So that's how they might add an extra mark, or that's how they might try to trick you, right? Remember, how do we define, or what is the units for a momentum? It is kilograms per meters per second. Okay, so if they give it to you in grams, okay, you need to convert the grams to kilograms before you put your answer into the calculator, or before you write your answer down, or show them the conversion factor. Okay, in our case, in this question, it's easy in kilograms, so we're fine, we don't have to do anything. Okay, truck moving eastward at 9 meters per second. So you're going to take 600, which is the mass, multiplied by V. So M multiplied by V, 600 multiplied by 9. Okay, 60 multiplied by 9, and that should give you a specific answer. You guys can calculate the answer. It's fairly straightforward. Okay, the second one, 1,000 kilograms. It's again in kilograms, so we're good. And this car is moving northward at 20 meters per second. Okay, so we have 1,000. P is equal to M times V. Okay, M is 1,000 kilograms. V is 20 meters per second. You calculate, you get your answer, and your answer must be in kilograms meters per second. Then 40-gram box pushed southward at 2 meters per second. Okay, 40 grams. Now, grams in this case is not the correct SI unit for momentum. Okay, because remember, we are calculating, or our answers need to be in kilograms meters per second, right? So this 40 kilograms needs to be converted. Sorry, this 40 grams needs to be converted to kilograms. Okay, and so we need to know the conversion factor. From 1 gram is equal to 1,000 kilograms. Okay, and so we convert the 40 grams to 1,000 kilograms. To a kilogram. Once we got our answer, we then multiply it by 2, and that would be our answer in kilograms meters per second. Again, this is all revision. We have gone through it last week, so it's basically just a recap. Okay, so now we know that P is equal to M times V. Okay, Momentum is equal to an object's mass times its velocity. That was last week's recap. Today, we are going to be talking about impulse, okay? And we will see that all of these things are linked together, okay? Everything is linked together. They're all interlinked like this, okay? So it's important, for some of us, this might be a basic, okay? But it's important that we understand how to just do the basic calculations in order that so when we get to the complex calculations, we know how to fit the complex calculations into, or we know how to fit the simple calculations into the complex calculations, and we can somehow figure out how we're going to work from there. So now we said we understand, or we now understand basically what momentum is. Okay. So now when we talk about, we basically, momentum was just an object's mass due to its motion. Okay. Now when we have a change in the momentum, so let's understand this very carefully. Okay. When I talk about change, okay, in physics, when we speak about change, okay, we are speaking about beginning and we're speaking about end. In physical terms, we say initial and final. Let me say that again. Okay. When I speak about change, sometimes we refer to it as delta. Okay. We are speaking about a beginning and an end. Okay. Unfortunately, in life, everything has a beginning and an end. Okay. And so it's mirrored in the work we do. Okay. So when we speak about a beginning and an end, in physics, we say initial and final. So I was basically just saying, if I am sitting and I'm just moving, or let's say, for example, if I'm weighing 50 kgs, I don't weigh 50 kgs though. I wish I did. If I'm weighing 50 kgs, right? And I'm walking at 2 meters per second, I'm walking. So it's going to be 50 kilograms multiplied by 2, that's 100 kilograms meters per second. That's my momentum. Okay? Now, when I'm speaking about change, I'm speaking about where I started versus where I'm okay? Or where I've ended off versus where I've started, okay? So when I speak about change, it's the initial minus final. So that is called impulse, okay? Because it's change, it's quick. I don't know if you've ever heard of someone saying, can I take your pulse? You know, the beats per minute. I don't know. I'm not really a cardiothoracic surgeon, so I don't really know all of that stuff. But it's kind of somehow related, okay? So impulse is something that happens very quickly. Like when someone will say, he acted very impulsive, it's like out of the blue, okay? It's in physics, you will see that the impulse is much smaller than the momentum calculation. Okay, so any object that is changing its momentum, okay, is experiencing an impulse. Okay, if my momentum is changing, I'm experiencing an impulse. Okay, and why do I do that? Because according to Newton's second law, which we are going to come to, there must be an unbalanced force that is on the system who's going to act on me. Maybe somebody kicked me with a ball or something, and now I experience an impulse because now there's a change in my momentum, right? So an impulse has to be caused by an unbalanced force, and I highlight that. That's important. I don't think a lot of students understand this aspect of impulse, okay? And so we're not going to dive too much into it, but just understand that an object's change in momentum, it's an impulse. They are going to ask you, define impulse or define momentum. You must be able to do that, okay? So impulse, we know that momentum, and we're going to come and see the relationship between all of this shortly, is that we know that impulse is equal to the change in an object's momentum. So now the velocity is changing, which means I must have a final and I must have an initial. So the standard formula would be impulse is equal to delta V, okay? But because it's changed because we want to know an object's motion relative to its initial and final position, we must say final minus initial. So P is momentum final minus momentum initial. I hope that makes sense to everyone, okay? We're going to do some practice problems, and I want us to do some practice problems on the board. So I'm going to be writing, we will be doing this question together, and then afterwards there's going to be a sort of an exam practice problem that we are going to do together. Okay, so let's pull up the board. Okay, I hope everyone can see. So we have an object that is moving at. Let's quickly just go back to the slide so that we can write down all the information before we answer the questions, because we haven't written down the initial conditions of the question. So let's go back to the slide. Okay, is the slide up? There we go. Okay, so before we go to the board, let's quickly write down, or let's read the question together, and we are going to write down what are the initial conditions before we go to the board. Okay, so the practice problem says a ball with mass 0.5 kilograms is rolling along the floor with a velocity of 2 meters per second in the positive direction. Let's quickly backtrack. We said that momentum is a vector. If you guys remember what's a vector is something that has magnitude and direction. Okay? A scalar quantity only has magnitude, it has no direction. Okay? A vector quantity, it's going to tell me its magnitude and it must tell me its direction. That's how we define a vector. Okay? So here it's kind of baby steps. So here they're kind of giving it to you, but in your exam, you will have to decide which direction you're going to choose as positive and which direction you're going to choose as negative. But in this question, they are giving it to you. Okay? But in the next question that we're going to do, we will have to choose the direction as positive or negative. Okay? And you have to indicate that on your exam. Okay? So we have a ball. Its mass is, so I'm first going to write all the initial conditions, and then we're going to solve together. So we have this ball, and this ball is 0.5 kgs. Okay? It says it's rolling along the floor with a velocity of meters per second in the positive direction. Okay? So now we will say that it's rolling along the floor. That's its initial velocity. Okay? So the initial velocity is 2 meters per second. A foot kicks it, speeding it up for 3 meters per second in the positive direction. Okay, so remember we spoke about impulse, and we said that impulse is caused by an unbalanced force. So now the thing was moving at 2 meters per second, its initial velocity was 2 meters per second, 2 meters per second, and now someone kicked it, and now it's 3 meters. Now immediately it changes. Okay. The momentum is now changing because impulse is changing momentum, right? So now the final is equal to 3 meters per second. Okay? So now we have three questions. They say what they want to know: what is the ball's initial momentum, what is the ball's final momentum, and what was the impulse of the ball. So let's quickly go to our board and let's solve this question. Okay, you can see on the board here, I have my initial conditions. I have the mass, I have the initial, and I have the final. So they want to know, now they wanted to know what was the ball's initial momentum. We know that momentum is equal to mass times velocity. So the mass in this case is 0.5 kg. And the initial is 2 meters per second. And then you are going to get an answer in kilograms meters per second. Okay. So this is how you are going to do every single question that is asked of you. Okay. You first write down your equation. Okay. You write down your equation. Once you've written down your equation, you then substitute. Okay. But this is basically very straightforward. So you will substitute your answer. Once you substituted your answer, you will then get your answer in kilograms meters per second. I do not spoon feed, so I will leave this for you guys to enter. Okay, and we will see the marking at the end. Okay, so that's your initial momentum. Then they ask again, what's your final momentum? Same thing. Okay, P is equal to M times V. The mass stays the same. Okay, velocity is 3 meters per second, and you will get your answer. Okay, now you could write it in both ways, but just remember, you don't have to substitute in your values or sort of your units while you're busy calculating. You can do that at the end, but just remember to do it at the end. Okay, does that make sense? So now you're gonna have two values. Okay, hypothetically speaking, if I had, let's say my final velocity was 28 meters per second, and this is my final velocity, and my initial velocity was 30 meters per second. Okay, let's make it 8. So let's say it was 8 meters per second. Okay, that's my final velocity, that's my initial velocity. The second question is the third question was what is the impulse? Okay, what is the impulse? So the impulse we said was, the impulse would be pfi minus, so momentum, the final momentum minus the initial momentum. Okay, and so if the final momentum was 28 minus 8 is the initial, which means your impulse will be 20 meters per second. Okay, so that's exactly what you need to do for this question. Okay, so we calculated the initial momentum, we calculated the final momentum, and then basically just to calculate the impulse, you just get the difference. So you take the final minus the initial. Okay, I hope that makes sense. Let's go back to our slide. All right. So, A, we got the initial momentum. B, we got the final momentum. And C, what was the impulse? So the impulse we said would be the difference. I want you guys to calculate this, okay? Simple, very straightforward calculations, okay? You plug in, you get your answer for the initial, you get your answer for your final, and then you get the difference, okay? Then, so the second part of impulse and momentum deals with its relationship to force. Okay, so now we've talked about how the change in momentum is referred to the impulse. And we know that impulse must be caused by an unbalanced force. Okay, impulse must be caused by an unbalanced force. Okay, so how are force and impulse related to each other? Please, this is very, very, very important. So I want everybody to be paying attention at this point. Okay, I'm going to come back to this later on when we're doing a different topic. Like I said in the beginning, all of these things are linked. Okay, they are all linked together. So remember, we said that impulse must be, you cannot have an impulse if there was not a unbalanced force acting upon the object, right? So let's say I'm walking past a park and my momentum, let's say, is 15 kilograms meters per second. And one of the boys kick me at the park. So now, let's say now my momentum changes to, I don't know, 20 kilograms meters per second. Okay, so I went from 15 to 20. I've changed. My momentum has changed, right? So that now I will refer to as the impulse, okay? Because what happened? What caused my momentum to change? The unbalanced force, like the ball hitting me, changing my momentum. Because I was going fine at my 15 meters per second. I was taking my own time walking, okay? So how do we relate impulse to force? Okay, so we say that impulse is going to equal to the force multiplied by the time. Okay, let's just work with each other here slowly but surely. So impulse is the force multiplied by the time. Okay, because remember, it's changing momentum. We said now that impulse is final momentum minus initial momentum. That's all well and good. That's not wrong. That's still correct. The impulse is still final in terms of momentum. Impulse is still final minus initial. But impulse can be explained in terms of momentum, and impulse can be explained in terms of force. Both ways. And all are equal to each other. Okay, so now if you put it all together, the change in momentum, okay, change in momentum is P is equal to M times V. Is equal to the impulse. Impulse is final minus initial, which is equal to force multiplied by time. Change in momentum is equal to the impulse, which is equal to the force. Okay, I'm going to repeat that again. The change in momentum is equal to impulse. We said that impulse is change in momentum, right? But we also said that impulse is equal to the force multiplied by the time, which means all of those three are equal to each other. If I have a change in momentum, that will equal to my impulse and will also equal to my force multiplied by my time, which means in that equation, if you can look at this line here, I can ask you to find time. I can ask you to find final momentum. I can ask you to find initial momentum. I can ask you any one of those variables in that equation because you can equate them all together based on the definition that I just gave. Okay, so change in momentum is this. Yes, do you agree that change in momentum is final momentum minus initial because change in momentum is equal to impulse. So change in momentum is equal to impulse, and we know that impulse is final minus initial, which is equal to force F multiplied by T. Okay, so now the last thing that we are going to look at now, because now we're going to bring all of this together. Okay, we're going to bring impulse together, we're going to bring force together, we're going to bring momentum together, and we're going to ask them. Impulse and momentum, this is a typical exam question. You can see it's worth 12 marks. It's not something that we need to, it's not one of the very difficult topics to understand. So I would say we could really score our marks if we could understand the impulse and momentum question. We could score quite well. We just need to apply ourselves correctly and practice. Okay. So let's read what they are saying here. Okay, it says dancers have to learn many skills, including how to land correctly. A dancer of mass 50 kilograms leaps into the air and lands feet first on the ground. Now, guys, they like physics. They like giving stories, unnecessary stories. We do not care about the dancers. We care about their velocities and impulses, right? So do not get lost in translation. You know, when they say get lost in translation, you are so focused on all like everything up until basically the first two sentences are not important. Okay? It's not important. They're just giving you a scenario for you to think of in order for them to give you the information. What's important is from the third sentence. The third sentence is she lands on the ground with a velocity of 5 meters per second. Okay? As she lands, she bends her knees and comes to a complete stop in 0.2 seconds. Now let's stop there quickly. A dancer, she has a mass of 50 kilograms. All right? She lands on the ground with a velocity of 5 meters per second. Is that initial or is that final velocity? So this is where you need to filter out the important information that you need. Okay? It says she lands. She didn't jump. Jump would be initial, right? So she lands on the ground with a velocity of, so I have my mass and I have final velocity. Final velocity. So there I can really do P is equal to mv, but that's for final. Okay? It's not the impulse, it's just the momentum. Okay, and then she said she bends her knees and comes to a complete stop in 0.2 seconds, which means if I'm seeing time there, I'm going to somehow have to relate it to force. So why? Why am I saying this? Is because if I have my impulse and I have force, then I have to have time. So if they give you time, then the minute you see time or the minute you see force, you must relate it to each other. Like, okay, now they're giving me time. Why are they giving me time in impulse and momentum? Just know it's related to the force. Okay. So, number one, calculate the momentum with which the dancer reaches the ground. Easy. Why? It's only 3 marks. Actually, 3 marks is a lot. It's supposed to be 2 marks. Okay? But they're being generous. Okay? P is equal to M times V. For number 1.1, I'm going to guide you through the questions. Okay? I'm not going to give you all the answers to the questions because I want you to sit and think about it and go and do it. It's going to be up there for you to see, to take down, to screenshot. So digest it. Okay? And the answers will be at the end. So the important thing is for you to know and understand how you need to solve it. Okay? So calculate the momentum. Momentum is P is equal to M times V. What is M? 50 kgs. Is it in the correct? Is it in the correct SI unit? Yes. What's V? Because they're saying calculate the momentum with which the dancer reaches the ground. They didn't say calculate the momentum with which she jumps because we don't know her initial velocity. I don't know what she went up with. I just know what she came down with. Okay. So it's going to be P is equal to M times V. M 50, V 5 meters per second. You get your answer, and your answer must be in kilograms meters per second. 1.2, define the term impulse. There we go. Impulse is defined as an object's change in momentum. Okay? Or however, whatever definition you guys also have and you understand it better, that's totally fine. Okay? Then 1.3, calculate the magnitude of the net force acting on the dancer as she lands. Okay? Now, we're going to assume in this case that the initial velocity is 0. Why? Because they didn't give us any information and we cannot solve this question without the initial velocity. Okay, so we're going to assume that the initial velocity is 0. Okay, because we have the final velocity. So let's go back quickly. I'm just going to guide you on this question step by step. The force. Okay, so basically you need this equation. Okay, so we're going to assume that the initial velocity is going to be 0. Okay, the final velocity we have because that's what she lands with. Okay, force we don't have, and time we have, which means you guys need to make if the subject of the formula. I already told you that the initial velocity is going to be 0. Okay, the final velocity you've already calculated in the previous question. It's P is equal to M times V. So you have M and V. Okay, you're looking for force and time you also have. So if you have all the components of this equation except for if. Okay, take a minute to, if you want to pause this, pause it, listen to it again, or backtrack if you have to. Just listen to how you are going to solve this step by step. Okay, so that's very important. Okay, I do want us to just sort of understand a little bit more. So we are going to answer 1.4 and 1.5, but basically just with regards to the impulse and momentum, just to reiterate basically what you've been saying. Okay, so they are saying assume that the dancer performs the same jump as before but lands without bending her knees. Will the force now be greater than, smaller than, or equal to the force calculated in 1.3? So technically, you cannot answer this question without knowing what the force is in 1.3. So I'm going to leave these last two questions for you guys to sort of tackle. And then when we start our next lesson, I'll probably just come back to it a little bit, come back to this question, give you the answer, okay, and basically discuss why that's important, okay. Or there will be answers attached at the end of this document. So when you have gone through it and when you have done it and when you have practiced it, you can look at the answers and see whether it was correct or not. Okay, and so I hope this has helped very much. I hope that you guys understand impulse and momentum a lot better. I hope you have taken something away from it, and I hope that you will go now and sit a little bit and practice, so that you can basically better your understanding. Until I see you next time, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum salam wa rahmatullah and assalamu alaikum wa rahmatullah to all of our beloved viewers on the Voice of the Cape's YouTube and Facebook page. We would like to once again thank our beloved sister Zainab Afrika, beloved sister of mine, for so beautifully rendering the content for physics for all of our beloved matriculants who are preparing for their upcoming trial examinations as well as their NSC examinations. As a reminder to the beloved listeners, this is the Voice of the Cape's online matric revision program for this year 2024, and of course the matric revision program or the Voice of the Cape is proudly sponsored by the Two Oceans Graduate Institute, which is an accredited online platform where you can become a primary school or high school teacher by studying in the privacy of your own home. And for more details you may find out from the website page, and that is the visit www.togi.ac.za, or you may call the number 021 829 7015, and that is for more details regarding the Two Oceans Graduate Institute if you would like to find out more information from them, which is the official sponsor of the Matric Revision Program. Once again, as a reminder to all of our beloved viewers, to all of those who have family members who are in matric, friends who are preparing now for the upcoming examinations, please ensure that you like and share this page, the YouTube link, as well as a Facebook link to all of the matriculant students out there, specifically those who are doing physics, a very, very difficult subject indeed. But Alhamdulillah, through the great assistance of our facilitator, Sister Zainab, we hope that everyone who is writing physics will be able to have the best of success in preparing for their physics examination. Once again, on behalf of all of us here at the Voice of the Cape, on behalf of my senior as well, who stood in for me earlier, Conita Kamar, and myself, Amir Adams, we'd like to thank you very much for viewing today's session. And as a reminder, please forward this to all of the students who need to prepare for the upcoming physics examinations. Of course, we will be having more sessions in the coming days and weeks, inshallah, pertaining to the different subjects that we will be having, where we're basically giving off advice and discourses for our matriculant students in order to prepare for the various papers that they have coming forth for them, inshallah. We wish the matriculants all of the very best. And once again, on behalf of all of us, we'd like to thank our esteemed facilitator for today, that is none other than Sister Zainab Afrika, for so beautifully rendering the discourses regarding preparation for physics paper 1. We wish you everything of the very best. Shukran, jazakallah khair. Thank you very much. Wassalamu alaikum wa rahmatullah.